That is KMNO4, which is a stronger oxidizing agent, right? Okay. And also we we use acid. Few drops of acid is also added. Few drops of acid is also added, which can be used as a catalyst, which is used as a catalyst. And in a lot of reactions, you would see that, okay, how can we represent this? How can we represent this, right? So you will see MnO4 minus slash H plus. Okay, slash H plus. That is the representation of a strong acid. That is the representation for a strong acid. Okay, that is the representation for a strong acid, right? Or what would be the observation? What would be the observation, right? So observation is observation is purple to colorless. Purple to colorless. Because the color for KMNO4 is purple, and if you are going to use or in this reaction, so you will see that the color of the potassium manganate would be decolorized basically. So it would be changing from purple to colorless after the addition. After the addition, okay. And then we would be doing two types of oxidation. We would be doing two types of oxidation. Number one, oxidation with cold KMNO4 and oxidation with hot KMNO4. So there are two types of oxidation in this. Types of types of oxidation reaction, वो दो तरह के होंगे. Types of oxidation reaction. Number one, number one is number one is with with cold KMNO4, okay, or number two with hot KMNO4, with hot KMNO4. That's it. Okay. So first of all, we would be doing with cold KMNO4. First of all, with cold KMNO4. Oxidation with cold KMNO4. Okay. So remember, in this oxidation, you will see only pi bond would break. Pi bond would break. Like, and the product would be diol. Diol is formed. Remember. And also, let's suppose this is the first reaction, that is ethene, and I'm going to add KMNO4 KMNO4. And this is also known as acidified KMNO4. Acidified, acidified KMNO4. And I told you acid is used as a catalyst, okay? Acidified KMNO4. Acid is used as a catalyst. So this is ethene, and I am going to add, you can say, MnO4 minus slash H plus. This is an ionic form of KMNO4. You can also write the full form, but I think so this is good. So, and the condition is cold. I'm not going to provide any type of heating in this. So I would see K double bond would break, that is the pi bond, and as a result, diol is formed. And as a result, diol is formed. I mean to say OH and then OH. This is called diol. This is called diol. As you know that oxidation is the addition of oxygen. Oxidation is the addition of oxygen. So that's the reason when you are going to do oxidation of cold KMNO4 in any alkene, whether you have ethene, whether you have propene, whether you have butene, okay? So the thing is that if you have double bond, so the double bond would break down. Okay, so the double bond would break down and you will see OH and OH would be attached. This is called diol. Alcohol is formed, but this is diol. So one double bond is equal to two OH. Remember, one double bond, one double bond is equal to two OH groups is equal to two OH groups. And let's suppose you have this compound, double bond, double bond, and this is the branch. Okay, this is the branch. So ultimately the condition is the same, that is MnO4 minus slash H plus, and condition is cold, acidified KMNO4. So what I would do, I would be breaking down the pi bond just like that. I would be breaking down the pi bond and I would be attaching OH. One double bond is equal to two OH. So the two double bonds are equal to four OH. Okay.
Sir, can you minimize your screen? I want to take a screenshot of this whole thing. Okay, sir, I took. You can do it normal.
Okay. चलें जी अब देखिएगा जरा लेट्स सपोज दिस इज द रिएक्टेंट ओके again I'm doing the same thing. I'm doing the same thing. Okay, or again the same thing, again the same thing. Obviously I would be removing the double bond and I would be adding OH and OH. Okay, that's it. This is your product. सो कॉन्सेप्ट ये है कि डबल बॉन्ड हटाओ OH लगाओ, डबल बॉन्ड रिमूव करो OH लगाओ. That's it. That's it. Okay. So this is called oxidation of alkene with cold KMNO4. So this is very easy. Just you have to break down the pi bond and then just attach OH on that. इसमें कोई मतलब लंबी चौड़ी बात नहीं है. It's very easy. It's very easy. Okay. अच्छा जी. Then you will see in this style as well. The examiner would be giving you this CH3, then this, then CH, then CH2, then CH, and then CH, then CH2, and then CH3. And he is saying that you have to add cold KMNO4, the same thing. Obviously, this is the condensed formula. It would it would be quite difficult for you to identify where the OH should be attached in this structure. So obviously, if you are good at displayed formula, so obviously you have to draw the displayed formula first so that you can see where is the double bond, and then you are supposed to attach OH groups on that double bond. बिल्कुल easy है. But if you are good at like in identifying the condensed formula, so obviously you know that when you see CHCH, when you see CHCH, it means that this is the double bond. It means that this is the double bond. So what I would do, see this. I know CHCH is double bond. So directly I would be doing this. K SA, and then just like that. Okay. This is OH. This is OH. This is OH. Okay, that's it. So one double bond was there in this structure, so I have added the two OH groups on that double bond. But the thing is that if you have alkane in the reactant, let's suppose this is the reactant, okay? This is the reactant, and you are going to add KMNO4, acidified KMNO4. The same condition you are going to provide, so then you will see there would be no reaction. क्योंकि double bond is mandatory ना. If you don't have double bond, so how can you expect that the product would be formed? So if there is double bond, so you would be having product. If there is no double bond, so there is no reaction. That's it. Okay. Acha. Then we have with hot KMNO4 oxidation oxidation with hot KMNO4. Okay जी, oxidation with hot KMNO4. So